Good afternoon, everyone. Today, we are going to discuss counting rules. I am Nazie Dulnuan, and I'm with my partners, Aljon Ballan, together with Arman Manalac. Many times, a person must know the number of all possible outcomes for a sequence of events. To determine this number, 3 rules can be used. It can be fundamental counting rule, permutation rule, and combination rule. First rule is the fundamental counting rule. It is stated that in a sequence of n events in which the first one has k1 possibilities and the second event has k2 and the third has k3 and so forth, the total number of possibilities of the sequence will be k1 multiplied by k2 multiplied by k3 multiplied by kn. Note, in this case, n means to multiply. So we have here an example to elaborate fundamental counting rule much better. Tossing a coin and rolling a die. A coin is tossed and a die is rolled. Find the number of outcomes for the sequence of events. We know that when we toss a coin, it's either heads up or tails up. And we also know that a die can land with one of the 6 numbers showing face up. Therefore, the solution is 2 times 6 is equal to 12 possibilities. A tree diagram can also be drawn for the sequence of events. A coin can be either heads or tails. A die has 6 faces of numbers which are 1, 2, 3, 4, 5, 6 for heads and for tails, resulting heads 1, heads 2, heads 3 to heads 6, and tails 1, tails 2 to tails 6. So we have 12 possibilities.
Types of paint. A paint manufacturer wishes to manufacture several different paints. The categories include color, type, texture, use. Under color, we have red, blue, white, black, green, brown, and yellow. Under type, we have latex and oil. Under texture, we have flat, semi-gloss, and high gloss. Under use, we have outdoor and indoor. So how many different kinds of paint can be made if you can select one color, one type, one texture, and one use? So here is the solution. You can choose one color and one type and one texture and one use. Since there are 7 color choices, 2 type choices, 3 texture choices, and 2 use choices, the total number of possible different paints is 84. You have to multiply the number of color, type, texture, use. For color, we have 7. Multiply by type, we have 2. Multiply by texture, we have 3. And multiply by use, we have 2 is equal to 84.
Another one is the distribution of blood types. There are 4 blood types: A, B, AB, and O. Blood types can also be Rh positive and Rh negative. Finally, a donor can be classified as either male or female. How many different ways can a donor have his or her blood labeled? Since there are 4 possibilities for blood types A, B, AB, and O, and 2 possibilities for Rh factor, which are positive or negative, and 2 possibilities for the gender of the donor, either male or female. We multiplied 4, 2, and another 2, resulting 16 possibilities. We can also draw a tree diagram for the distribution of blood types. We have A, B, AB, and O for blood types, and each blood type is either Rh positive or Rh negative. And in every Rh, the donor can be male or female, resulting 16 different ways can a donor have his or her blood labeled. We have here an important note. When determining the number of different possibilities of a sequence of events, you must know whether repetitions are permissible. To further understand, let's have an example. Identification cards. The manager of a department store chain wishes to make 4-digit identification cards for her employees. How many different cards can be made if she uses the digits 1, 2, 3, 4, 5, and 6, and the repetitions are permitted? Since we have 4 spaces to fill on each card and there are 6 choices for each spaces, first thing to know that the 6 digits can be used in the first space. And since repetitions are permitted, we can also use the 6 digits in the second, third, and fourth spaces. Therefore, we multiply 6 4 times itself to get the total number of cards that can be made. 6 times 6 times 6 times 6 is equal to 1,296. Finally, we can have 1,296 different cards. But what if repetitions are not permitted? In the same situation, but in here, repetitions are not permitted, we also have 4 spaces to fill up on each card, and there are 6 choices for each spaces. We know that in the first space, we can use 6 digits. We can use 1, 2, 3, 4, 5, and 6. But in the second space, we can't use 6 digits because repetitions are not permitted. Therefore, we subtract 1 digit from the 6 digits and we only got 5 digits left to be used in the second space. So in second space, we can use 2, 3, 4, 5, and 6, but not 1. The same process goes in the third space. We subtract another 1 digits and we can only use 4 digits, which are 3, 4, 5, and 6. We can't now use the digit 1 and 2. Lastly, for the fourth digit, we also subtract 1 digits from the 6 choices, so we got 4, 5, and 6 left. So we have 3 digits left for the fourth space. In summary, If repetitions are permitted, then the numbers stay the same going from left to right. If repetitions are not permitted, then the numbers decrease by 1 for each place left to right.
Now, we're going to look what factorial is. This exclamation point does not mean you're really excited about n. It is actually called the factorial, and you would read this as n factorial. What it means is you're going to multiply a sequence of number. For example, if I have 6 factorial, that would mean I multiply 6 times 5 times 4 times 3 times 2 times 1, and that is 720. So, I take the value of n and multiply the integers down to 1. To use the formulas in the permutation and combination rules, a special definition of 0 factorial is needed, which 0 factorial is equal to 1. Permutation is used when we are counting without replacement and the order matters. If the order does not matter, then we can use combinations, and we will talk about that later on. Permutation. A permutation is an order of n objects in a specific order. Very important that it is in order. For example, a lock that has a combination of 11, 06, 20. It must be 11 first, then 06, then 20. If you change the arrangement like 06, 20, 11, then the lock will not be open. This is a simple example of permutation.
Permutation rule. In permutation rule, the arrangement of n objects in a specific order using r objects at a time is called a permutation of n objects taking r objects at a time. It is written as npr, and the formula is n permute r is equal to n factorial over n minus r factorial. The notation npr is used for permutation. How to use this formula? For example, we have the given n is 6 and r is 4. 6 permute 4 means 6 factorial over 6 minus 4 factorial, or 6 factorial over 2 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1 all over 2 times 1. Cancellation process, we cancel 2 and 1. And proceed to multiplication. We multiply 6, 5, 4, and 3, resulting 360. Let's try it. Situation. Suppose a business owner has a choice of 5 locations in which to establish her business. She decides to rank each location according to certain criteria, such as price of the store and parking facilities. How many different ways can she rank the 5 locations? 5 locations were taken and then arranged in order. Hence, n is 5 and our r is also 5. 5 permute 5 is equal to 5 factorial all over 5 minus 5 factorial is equal to 5 factorial over 0 factorial is equal to 5 times 4 times 3 times 2 times 1 all over 1, because 0 factorial is equal to 1. We cancel 1, then multiply the other remaining value, and we got 120. Therefore, there are 120 different ways that she can rank the 5 locations. In the same situation, but she only wishes to rank the top 3 of the locations. 3 locations were selected from 5 locations, so Rn is equal to 5 and Rr is equal to 3. Hence, 5 permute 3 is equal to 5 factorial over 5 minus 3 factorial is equal to 5 factorial over 2 factorial is equal to 5 times 4 times 3 times 2 times 1 all over 2 times 1. Cancel out the 2 and 1 and proceed to multiplication. We got 60. So, there are 60 different ways that she can rank the locations.
Example 1. A license plate begins with 3 letters. If the possible letters are A, B, C, D, and E, how many different permutations of these letters can be made if no letter is used more than once? Here is the solution. By using reasoning, for the first letter, there are 5 possible choices. After the letter is chosen, there are 4 possible choices. Finally, there are 3 possible choices. We have 5 times 4 times 3 is equal to 60. Another one is by using the permutation formula. The problem involves 5 things: A, B, C, D, E, taken 3 at a time. So the solution is P53 is equal to 5 factorial over 5 minus 3 factorial is equal to 5 factorial over 2 factorial is equal to 5 times 4 times 3 times 2 factorial all over 2 factorial is equal to 60. There are 60 different permutations for the license plate. Example 2. In how many ways can a president, a treasurer, and a secretary be chosen from among 7 candidates? Here is the solution. By using reasoning, for the first position, there are 7 possible choices. After that candidate is chosen, there are 6 possible choices. Finally, there are 5 possible choices. So, we have 7 multiplied by 6 multiplied by 5 is equal to 210. Another one is by using permutation formula. The problem involves 7 candidates taken 3 at a time. Here is the solution. P73 is equal to 7 factorial all over 7 minus 3 factorial is equal to 7 factorial over 4 factorial is equal to 7 multiplied by 6 multiplied by 5 multiplied by 4 factorial all over 4 factorial is equal to 210. So, there are 210 possible ways to choose a president, a treasurer, and a secretary be chosen from among 7 candidates.
Combination rule. A combination is a selection of distinct objects without regard to order. We have here a situation. Suppose a dress designer wishes to select 2 colors of materials to design a new dress and has on hand 4 colors. How many different possibilities can there be in this situation? That is, if the designer selects yellow and red, this selection is the same as the selection red and yellow. This type of selection is called a combination. Yellow or red or yellow, it doesn't matter because in combination, order doesn't matter. We compare permutation to combination. In permutation, arrangement is important, while in combination, arrangement is not important. To further understand the difference between the two, let's have an example. Entitled Letters. Given the letters A, B, C, and D, list the permutations and combinations for selecting 2 letters. In permutation, we can have AB, AC, AD, BA, BC, BD, CA, CB, CD, DA, DB, and DC. Because in permutation, AB is different from BA. The process to get the combination is that we cancel out letters which have a duplicate, like AB and BA, AC and CA. So we cancel out BA, CA, CB, DA, DB, and DC. Because in combination, AB is the same as BA. Therefore, if duplicates are removed from the list of permutations, what is left is a list of combination. We have AB, AC, AD, BC, BD, and CD as our combination. Alternatively, BA could be listed and AB crossed out, and etc. The combinations have been listed alphabetically to convenience, but this is not a requirement.
Combination. Combinations are used when the order or arrangement is not important as in the selecting process. Suppose a committee of 5 students is to be selected from 25 students. The 5 selected students represent a combination since it does not matter who is selected first, second, etc. Combination rule. The number of combinations of R objects selected from N objects is denoted by N combined R and is given by the formula N combined R is equal to N factorial divided by the quantity of N minus R factorial R factorial. Let's apply this. The given R, N is 4 and R is 2. Therefore, 4 combined 2 means 4 factorial divided by the quantity of 4 minus 2 factorial 2 factorial, or 4 factorial divided by 2 factorial 2 factorial is equal to 4 times 3 times 2 factorial divided by 2 times 1 times 2 factorial. Then simplify 4 and will become 2. Then cancel out the 2 factorials, so the remaining is 2 times 3 divided by 1, and that is 6. Okay, so this is the combination rule and this is the permutation rule. Notice that the formula of combination is the formula of permutation with R factorial in the denominator. In other words, the combination rule is the permutation rule with R factorial, where R factorial divides out the duplicates from the number of permutations as shown in our past example. For each two letters, there are two permutations but only one combination. Hence, dividing the number of permutations by r, eliminating the duplicates. This result can be verified for other values of n and r. Note that the combination of n to n must be equal to 1. Let's try it. The newspaper editor has received 8 books to review. He decides that he can use 3 reviews in his newspaper. How many different ways can these 3 reviews be selected? This is a combination problem because it doesn't matter who is selected first, second, and last. The editor only needs 3 books to review out of 8 books, and we are looking on the possibility of these 3 books to be selected. So, Rn is 8 because it is the number of items in our set of books, and R is 3 because it is the number of items selected from the set. Therefore, 8 combined 3 is equal to 8 factorial divided by the quantity of 8 minus 3 factorial, 3 factorial, is equal to 8 factorial divided by 5 factorial, 3 factorial, is equal to 8 times 7 times 6 times 5 factorial divided by 3 times 2 times 1 times 5 factorial. Okay? Cancel out 5 factorials, and that is 56. Therefore, there are 56 possible ways to review 3 books on 8 books. Another example is, in a club, there are 7 women and 5 men. A committee of 3 women and 2 men is to be chosen. How many different possibilities are there? Here, you must select 3 women from 7 women, which can be done in 7 combined 3 or 35 ways. Next, 2 men must be selected from 5 men, which can be done in 5 combined 2 or 10 ways. Finally, by the fundamental counting rule, the total number of different ways is 35 times 10 is equal to 350 ways. Since you are choosing both men and women, using the formula gives 7 combined 3 times 5 combined 2 is equal to 7 factorial divided by the quantity of 7 minus 3 factorial, 3 factorial times 5 factorial divided by the quantity of 5 minus 2 factorial, 2 factorial. Then, cancel out, simplify, and that is 35 times 10, and there are 350 possibilities. And that is our report. Thank you and God bless.